This is the first two parts of integration. This is chapter 13 from the Pearson textbook. Integration is probably the largest chapter throughout years 12 and 13, or the largest topic. So it's really one you've got to get to grips with from day one. So not just understand the process, but as you go through, understand what is actually going on and what you're working out. The first part here relates to exercise 13a, and this is really about understanding the process of integration, understand how to integrate. It's the opposite of differentiation. So you all know hopefully how to differentiate by now, how to take an expression, differentiate it to get another expression, and this expression is the gradient function for our original expression or equation in this case. And the process you're going through when you differentiate it, as you'll remember, is you're multiplying these two together and reducing the power. So multiplying 3 and 5 together to get 15, reducing the power from 5 to 4. So if we're doing the opposite, doing the inverse, then we're just doing that process but backwards. So let's actually do it for this one. Let's see what the process is for differentiation and then work backwards for integration, and we can find out therefore how to integrate something. So if we're differentiating 3x to the power 5, the first thing to do is to multiply the power by the coefficient. So multiplying power by the coefficient. And then we're reducing the power by 1. So that's the process. So we multiply the power by the coefficient, that's 15, reduce the power by 1, x to the power 4. So that's how I get the 15x to the power 4. That's differentiation. Okay, let's follow these procedures but go backwards. So if I'm putting 15x to the power 4 in, instead of reducing the power by 1 for differentiation, I'm going to increase the power by 1. That's the first thing I'm going to do. So that will give me 15x to the power 5. And now I divide the coefficient by the power. Bear in mind, of course, if there's no coefficient here, that you treat it as 1. So increase the power by 1, so 15x to the power 5. Divide the coefficient by the new power, so that'd be 15x to the power 5 divided by the new power, which is 5. Now 15 over 5, of course, is 3. So you can see, working backwards, how we get from the differential to my original function. For 13a, we're dealing mainly with working backwards from the differential to the original function, but actually integration has all sorts of other uses other than just undoing differentiation. 15x to 5 over 5, of course, is 3x to the 5. So that's the process. Increase the power by 1, divide by the new power. Increase the power by 1, divide by the new power. When you have a function with several parts to it and you're differentiating, you can differentiate all the parts separately. Integration is just the same. Let's have a look. So to differentiate this one, I'm going to multiply by the power and reduce the power by 1. Multiply by the power, reduce the power by 1. And as we know, the gradient of a line y equals 2 is just horizontal. It has no gradient. So the number 2 differentiates to 0. Okay, let's work backwards. If the differential is 3x squared plus 10x Then we're going to integrate it. So let's integrate that. The integral is increase the power by 1, divide by the new power. So I had x squared, I'm going to increase it to x cubed. There's my 3, and divide by the new power. Increase the power by 1, well that's a 1 there, so we're going to increase it to a 2. There's my 10, and divide by the new power. Increase the power by 1, divide by the new power, which gives me x cubed plus 5x squared. Now you can see we have a problem here, because when I differentiated this, I got this expression. Integrating that, I got this expression, which is very similar to this one, but I'm missing the plus 2. The truth is, the differential of this expression is that, as we know, we're happy with that, but x cubed plus 5x squared plus 3 would also have that as a differential. X cubed plus 5x squared minus 78 would also have that as a differential. So when I integrate this, I need to make sure that I put a plus c on the end, because the integral of this is going to have a number on the end, and as yet I don't know what it is. So we need to write it as, in this case, x cubed plus 5x squared plus c. You will miss out a point if you forget your plus c on a lot of questions.